In this tutorial, I'm going to show you how to create a simple turned shaker pull for the drawer. One of the defining features of the shakers were their pegs and pegboards. Pegboards line the walls, rooms and hallways of all shaker buildings. Chairs, wall clocks, racks and shelves, clothes hangers and kitchen utensils were all hung up on these ubiquitous pegboards, and shaker orderliness and cleanliness were thus achieved. The smallest shaker-made pulls, like the pegs, were individually lathe-turned, and most are as graceful as pegs, but considerably smaller. The smallest measure a little over 6mm in diameter and 12mm in length. Others are as large as 40mm in diameter and 50mm in length. Some are even longer depending on their purpose. Clock doors, chest, table and even desk drawers, sides of washstands all had pulls. Indeed, pulls were installed wherever needed. This image is a sample of typical profiles for both shaker pegs and pulls. To make things easier, we'll just make sure we've just hidden everything. We're going to start with a new sketch. We're going to sketch off down here off the right sketch plane. I'll come in close because we're working on a pretty small scale. So alpha line, from the origin, I'm just going to come out to the left, press escape. I'm just going to turn that into a construction line. Come in really close so we can see this millimeter grid here. And I'll just pull that down a little bit. So I'm going to create a profile, for my sort of shaker pull design that it can rotate around. Now that might not make a lot of sense to you at the moment, but you'll see as I go through this what the techniques are. So alpha line, from the origin, I'm going to come up 4mm. Now because we're working at this sort of scale, you'll find that it'll snap to the millimeter line. So it'll just make things a little bit easier. So we'll keep going. I'm going to go 16mm this way. Now in the real world, you might end up with less here. When you're actually turning something on the lathe, you want to have a little bit of space here. And then we'll come up, say, another 4mm, go across one. Just going to pan along a little bit. And press escape, so we're not doing any more lines. Okay, now I'm going to create an arc. This time it's a 3-point arc. And I'm going from this point here, I'm going to come along 16mm to there. I'm going to bring that arc down so that it lines up with this original line here. And there's our midpoint. I'm going to do another arc. I'm just going to extend it sort of up this way a bit. And the other thing I'm going to do, I'm just going to put in a tangent constraint. It looks pretty good, but I'm just going to put a tangent constraint in there so that basically that then becomes one continuous arc. One more arc for this one. So again, it's a 3-point from this point here, and then I'm going to just sort of judge it up to here. And what I want to do, because this is actually the center of of my pull here. So when I make this arc, I don't want it sort of coming back like that. It'll kind of make it look a bit funny on the top. So I want it coming in, yeah, almost like at a tangent to this vertical line here. So about there. Okay. So we've got that. One more line, alpha line. So we're just going to go from that point there to that point there. Now you'll see that all of these lines here are blue. So they haven't been properly defined, and so they're not fully constrained. Sometimes that actually comes in handy, and this is where I'm going to show you how it comes in handy. Because it's not constrained, I can actually play around with this. So I might go, oh, actually I want it to look like that or that. I might want that to be down here. So there's a whole lot of things that you can sort of play around with here from that point of view. So it does have some benefits sometimes. I've just got to get that back to where I had it before, or roughly where I had it before. That'll do. So now that we've done that, we're going to do a different kind of extrude. So we better finish that sketch, and we'll zoom back in so we can see what's going on. So normally up till now we've been in here and we've just been doing the normal extrude. This time we're going to do a revolve. So we've selected revolve. We'll go to profile, make sure that it selects that, and then we go to axis, and this is why we put this construction line in here at first. So we just click on that, and there we go. Now it defaults to 360, and the operation is new component, and we'll go OK, and there you go. There's a really nice, elegant, simple shaker pull. Now what you can do now is actually go back to the diagram that I've given you and just see whether you would like to modify that at all. So for example, you know, when I'm looking at this, I might want to make that lip there a little bit thicker. And the other thing I might do, I need a constrained orbit. It's kind of not working too well. And I might just want to sort of make that edge there not so sharp as well. So you can go back into the sketch and play with it and change it.